Hello. So everybody likes gaming, right? Yeah. So since I was a kid, right, well, I started coding on like those small computers like the Spectrum and so on. And the thing is, I was 12, there was no internet, and basically means that you play a game over and over and over, and then you get bored, and then what do you do with it? So the world divided in two parts, the ones that stop playing and stop using the computer, and the one who learn how to code so you can code your own games. And I started like that, never stopped. I don't code games in my normal work day, but I do it at night just for fun. So this is like an arcade game. If you remember those big cabinets with coins, quarters, put in, play for 5 minutes, game over. Right, so I'm trying to do one of those, even get game over and everything else. Yeah, so that's it. Right, so there's my Twitter account if you want to follow me. A little bit more about me, apart from being an old geek and having learned how to code in BASIC. I have been a web developer since 1997. I worked for a lot of big brands, most notably for Stack Overflow for 3 years. I nowadays work for TopTal, obligatory pitch. It's a great company that allows you to work remotely all over the world and allows you to be a digital nomad, go around on the beaches and code and get a lot of money. We do it for real. If you have any questions on how to do that, there's a guy there with a t-shirt like me. Ask him. Okay, obligatory pitch over. Moving on. Okay. So what are we going to talk about? Okay, so this is the game I built. It's called Blasteroids, which is like obscenely 80s, even in the logo. Yeah, it has a like splash screen, and the game is really like an old-style arcade game, right? So you have a intro screen, and you have like levels, and you even have a high score where you can write your own name and so on. And of course, someone tried to hack into it and failed. Anyway, so that's the game. So this is the address. I'm going to give a demo at the end of the talk, because otherwise it's just a spoiler, right? So don't try it. It doesn't work on the phones. Just so you know. It needs the keyboard, basically. Anyway, so how do you build a game in the browser? And why? So that's the most important thing. Why would you, all that you can do with a computer, just choose a browser to write a game? Well, the reason is, first of all, I learned how to code games initially in BASIC. It's not a great language for games, but it's an accessible language, so it allowed me to learn how to code. And JavaScript, in my opinion, is the new BASIC, right? It's what is the most approachable language. It's in all the browsers. You literally press F11, you got a JavaScript command line right there. So yeah, why not? Second thing is, you know that everybody says JavaScript is slow, right? You heard that, right? JavaScript is fucking fast. Yeah, it's really, really fast. It used to be slow. Nowadays, it's jittered, and it's really fast. It's almost native fast. So you can certainly build a game in it. It's basically compiled by the time it runs. It doesn't matter. Also, in the browser, you get all the hideous part of game programming taken care of. Like, you need to take care of sound. Hey, the browser has sound API. You want to have video controlled pixel by pixel. Of course you can do it. You can do it with the Canvas API. So you have all the bits and pieces already in place, and you don't have to think about those things, and you can concentrate on game design, which is fantastic. The big difference from normal coding, so how many of you are actually front-end developers or know how to code JavaScript in the browser already? Yeah, about half of you, right? So for all the others, and just as a refresher, I hope you know, the browser is stateful, right? So what happens is that if you want to have, say, you have a piece of the screen like a div, and it's got a white background, and you wanted to make a blue background, so what do? You change some attribute of that bit of document in the DOM, and it will change. You change the state, and then by magic, it changes on the screen. You don't interact with the screen if you want to change something on the screen. You interact with an object representation of the screen, which is something that, from your point of view as a developer, keeps the state. You don't have to worry about it. You don't have to worry about screen size most of the time. You don't have to worry about printing stuff on the screen. So if I put like a command line on top of my browser, and then I move it away, by magic, your blue div is still there, right? You don't have to redraw it. The browser is doing it. In game development, you don't take that approach. In game development, it's like hardcore, take away all the frills because they are slow. And so what you do is you create a loop, and the loop, which is already there, is hidden in the browser, you take it over. So to explain myself a little bit better, normally, here is how you would write on a canvas, right? You acquire a canvas, you get it from your object world, which contains the state. You change the state of the canvas. The text hello world is there in 30 pixel Arial forever, right? If you want to write a game, that's not going to work. What you want to do is still get the canvas, but then every frame you repaint from scratch the canvas. So the canvas is completely rebuilt from zero, from literally a blank black box every 30th of a second, every 30 milliseconds. So basically, writing games is fitting as much stuff as you can, as much code as you can in those 30 milliseconds, so the next frame comes up. And the API that you use in modern browsers is window.requestAnimationFrame. Basically, it pauses the JavaScript execution, waits until you're ready to render the next frame, and it gives you the time to build it and then put it on the screen. And then you put the JavaScript in wait again. So you are not really using one core 100% of the time, but you are just using it when you have time. Right? So this is what it looks like, right? So the canvas is cleared, it's painted with your hello world, and then 30 milliseconds, or the remaining part of the 30 milliseconds is waited, and then the cycle. This loop happens continuously, and basically that's how it's done. So I'm going to have a few demos here. So just so you know, this is real. Okay, so let's see. Here we go. So a basic loop is like this. This is exactly the same code, right? If I put it up here. Yeah, as you can see, every 30th of a second, a new frame is generated. The code I've written has tix modulus 100, so it's always different, right? So you can see there is an animation. If I just take this off, you're just not going to see anything useful here, right? Just do this. Not great. So that's how it works. So once you have this loop in place, basically doing animations becomes trivial, sort of trivial. In the sense that you don't have to have some complicated routines in which you have to think about what did I draw here and there, and then I'm taking away the player from here, I need to put the background there, or whatever. It's brutal. So you just put in the background, put in the sprites on top of, next frame. Fast and quick. Okay, so that's the first step. Moving on. Let's see, second step. Right, so what do you want to put on the screen? You want to put sprites on this and assets on the screen. So what are those? Those sprites and assets are the things. Okay, so there are a bit of noises in this presentation. Do you like video game noises? Like, so if there is a sprite, maybe it goes. Yeah. So this is things that move on the screen. Okay, so what are they? Basically, they are images that we just copy over in the right place in the canvas. Like we put in that hello world writing, we can put in an image taken from somewhere. Of course, if you want to have the illusion of animation, you need to have different positions. So if you have an image of a walking man, you will have like the position like this, and then like this, and then like this, you know. And so if you alternate these images in the different frames, it will look like it's moving. And of course, you can change the position, so it's actually moving. And basically, so what sprites and assets are is just a series of images that you put on the screen. You calculate the position every frame, and then reprint it from scratch. Right, so in a very basic sense, in this code here, what am I doing? I'm just moving around the writing that was there before. So I am changing the position by 5 pixels every frame, and then wrapping it around when it goes off screen, otherwise it will just disappear. So again, if we just make this minimum change here, what you're going to see is that it moves, right? So now it's clear to see that we are actually starting to have a real animation here with different frames and so on. So if we were to do something more interesting, we need to do a few things. So first of all, we need to refactor the code a little bit, because like this, it's a little bit too much procedural. All in one place is not great. Right, so probably we want to create a class sprite which contains all the sprite data, so where the sprite is and how to calculate the next frame, given the ticks, which is like the timer, so what time it is. And if you want to draw, okay, it's going to pass only the position data in get x and get y instead of taking care of printing itself. Why? The reason is because you can have tons of sprites, like hundreds and hundreds of sprites on the screen, but in general, most of these will have the same images. So think about a shooter. A shooter, you have the projectiles. The projectiles are all exactly the same. You don't really want to create a new class which has a handle to a new image and prints the image every time. If you do this, you're going to have a million classes taking a lot of memory, a lot of stuff. You don't want to do that. So what you want to have is a class, which is called an asset, that knows how to print a bullet, and a class which is a sprite that takes care of the metadata of that image. And this is what we're doing here. This is a class here. And the drawing is separated. So here's the refactor thing using the sprite. And as you can see, it just called hello new sprite instead of initializing, hello update at every frame, and then it draws it. Then if you add the asset class, which is just a class that knows how to draw itself, well, you got everything you need, and you can put it together. And then at the end, you will obtain basically the same thing. So if we go back to the Visual Studio Code, you get first this, which is the same function, which has the sprite with the constructor and everything, and I'm sure you believe me, but it does the same thing, yay. And if you want to try with assets, again, whoops, wrong place, the same class will work the same way. So you have an asset class, and you're going to have one asset class for each different kind of image you have on the screen, and a sprite class, and you're going to have a sprite class for each moving object that there is on the screen, which can have one of the assets as a drawing. So to give a more interesting example, because, okay, we have had enough hello worlds for now, I built like a Super Mario thingy, right? So this is the same thing, right? It's literally the same code. What have I changed? Very little, right? What I've changed here is the fact that the asset, if you look here, the asset draws itself on the canvas. And I just changed the logic a little bit of walking, so instead of going on a diagonal, it goes straight. All the rest is literally the same, but as you can see, we have already something that looks a little bit like an arcade game, right? And this is what? 58 lines of code, including the HTML. So this is why I chose JavaScript. It's really powerful for this kind of things. So the idea here is that, of course, drawing one Mario requires you to allocate an image with all the frames of Mario. But what if you want to draw 10 Marios? So you can allocate 10 sprites, but one asset. And this is what I've done here. There are many Marios. And if you look at the allocation, there's only one asset, this one. But then there are 10 sprites. Yeah? So this allows me to save memory. And of course, on arcade games, arcade games originally ran maybe on a Z80 CPU or 6502. They were really, really small machines with kilobytes of memory. So this kind of stuff was essential. But it's actually a good design paradigm, so it's great. Another thing that is very useful in having this separation and having assets separated is that you can build all your assets before you start the level, right? So I was chatting with some other people last evening, and I said, oh, we tried to do a game, but then it used to pause in the middle, and because there was some garbage collection happening, right? So because we are creating too many images, too many objects, and then after 5 minutes you play, it's created so many objects that there is no more memory, and then the browser needs to shrink the memory and get away all the old stuff. And this doesn't happen if you do this, right? If you do this, the big things you allocate are always the images or the sounds, but in this case the images, they are allocated at the beginning of the level when you create all the assets, so all the list of possible things that you're going to draw on the screen. And then you just worry about drawing as many as you want as you go on without duplicating the effort. By the way, if anything that I'm saying is unclear, yeah, just stop me and I'll try to answer. Okay, so that's that. Next thing is, in a game, of course, is keyboard input, right? So what good is a game if you can't command it with a gamepad or a keyboard or joystick or mouse or whatever, your voice? Anyways, input is important. I'm going to concentrate on keyboard input because it's quite typical in this kind of games. But the game I've developed also supports a gamepad, and it's literally the same thing. So I have a sound for this. And yeah, the sound for this is this one, yeah? It doesn't work. Okay, this one. There we go. Right, so keyboard. You press the keyboard, you hear zaps. So let's see, what do we want to do with the keyboard? So there is a problem with the way browsers handle keyboard. And if you have tried the naive way of listening to a keyboard in JavaScript, it's not going to work. Right, so there are two events that are mostly interesting, key up and key down, that correspond on when you press a key and when you release a key. And so what happens normally? What happens normally is that if you bind to that and you listen when you press a key and the key is being pressed, you don't know, you don't really have a notion of the key being kept pressed. So you need to track when the key is pressed and when the key is released, and then keep the state somewhere. So what I did here, I used the set, which is like an array, basically, that just tells you if something is in it or not. And I just store in it all the keys that are being pressed and remove the keys that are not being pressed. So instead of listening to events, the application can just look into this class and see what keys are pressed at the moment. And this works because, okay, there are some limitations based on the keyboards, but if you are pressing 10 keys, like ASDFG, for example, at the same time, this will actually handle the fact that you have A, D, S, F, G pressed at the same time. If you're just looking for what is appearing on the screen or what keys are being pressed, you can't, because you usually get like even one key as the answer to this kind of event. So it's really, really not going to work Instead, if you want, for example, your spaceship to move up and to move right, but also upright, and these keys are like not the cursors, you need this kind of structure here. And so we can do something interesting right now, right? So we can make Mario jump. So how do we do it? Well, the most important bit is this part here, right? So what do we do? So if Mario is not jumping, so jump equals 0, and the keyboard has key J pressed. So key J means, of course, J like jump. Then I'm going to store a number, which is the size of this jump pattern array in jump. And that's it. Now, what happens is that the next time I get here, jump is not 0. And if jump is not 0, then I'm just going to go down that array, and I will use that array to shift the position up of Mario. Right? So as soon as I press J, the position will go up by 5, and then the next tick, up by 10, by 15, by 20, 24, blah, 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 blah. In the end, go back to 0. So it goes up and down. Right? And again, as you can see here, this is where the jump happens, right? So I don't change the position, I just return a different position. So if Mario is going at Y of 50, and I'm inside that pattern, then this will shift it up by the required amount. So this is how jumps work usually, and it works really well. You just need to do this array in a decent way, otherwise it's going to look really awkward. But it works, yeah? So this is Mario, yeah? And if I press J, it jumps. Yeah, it looks like a real jump. It's almost like a, yeah, wee. Come on. Have you seen these 10 lines of code? It's 10 lines of code, guys. You can do it. I swear I spent more time finding the right way of making it jump so it looks like Mario than writing the code. It's just amazing what you lose your time on. Okay, so we have Mario. Mario is jumping. What do we need? Right, so let's see. Let's put in another barrel, some enemy, right? So again, the code is getting a little bit more complicated, but it's not that complicated, right? So it's, what? 149 lines, still small, relatively small. So what you have here, basically, the new bits. Okay, stop this. Okay, this is the keyboard handling. The sprite, this is Mario sprite, is the same. Okay, that Mario, you haven't seen this because it's not really neat. Okay, we have a barrel, right? And the barrel, what does it do? It just moves, right? So this is the movement, again, in the update. And what does it say is it moves left by 3 pixels, and then if it hits 0, it starts from the right. That's it. Now we have two assets. Yeah, this is Mario, and this is the barrel, right? So again, following the same pattern, we just add the two assets and two different behaviors, and now we have two things moving on the screen. Yeah, the code that in the main loop is still very, very clean. Yeah, there's not much in it. And what we're building in the beginning is not that much stuff. Okay, so now we have two things, right? So we have Mario, which is running, and the barrel, which is rolling against it. And of course, we want to jump. So we can jump, right? Let's see if it works. Whoops. Maybe not. Okay, so let's close this. And I wrote J somewhere else. Yeah, barrel. Okay. Live demos for the win. Okay, here we go. Yeah, so we can jump and we can actually avoid the barrel. But of course, if I just screw it up, like, oh no, I'm drunk, I'm gonna hit it. Yeah, nothing happens. So it looks more like a game, like it looks like we can jump stuff, but damn it, we need, yeah. collision detection. And this is the next thing I'm going to talk about. Surprise, surprise. Here we go. So, collision detection, hit detection, right? So when you have I have the boom here. There you go. So, how does it work? Okay, so explanation about Dead Mario. Dead Mario is a sprite. So when you read sprite, think about behavior or something on the screen. Is a Mario, so it's an asset of Mario that falls down. It goes, woo! And we just use it for showing you that you're dead. The barrel class I already talked about is a barrel that moves left, and there is a barrel asset. Now, the trick of doing hit detection is this. You have two rectangles, which are the two sprites, and you need to detect when they are one on top of the other. Now, this is apparently not a super easy problem, but there is a trick. And the trick is this. In 99% of the cases, not 100%, but in the cases that we handle, the condition by which one sprite is over the other is that one vertex is inside the rectangle of an asset. One of the four vertices, right? So if you think about a sprite being a square like this, right? It can be like overlap like this, overlap like this, or like this. In either case, the vertex of the second rectangle is inside the first. So basically what you need is something like this, pointing rect, something that returns true if one point is inside the sprite. And then, you just use it 4 times, one for each point of your Mario, and you will determine whether, one of the 4 black dots is inside the green, just to be clear. Of course, this doesn't work if you start to have things like sprites of different dimensions, and then one can totally overlap it, and then all the vertices are out, and so on. So this is very simple, but it works for the kind of game that we're building. So that's the technique. Of course, I've simplified here, and I didn't really want to have sprite 1, sprite 2, sprite 1, sprite 2. Everywhere I use constants, and it's a little bit mind-boggling, but once you get the hang of it, you can write it. You write it once, then you maybe write some tests if you want, but tests usually are even more complicated, so I don't know. Anyways, works. So that's it. So let's see if that works. So let's go over what we built. And now we have, let's see. So our keyboard, we got it. Sprite, we got it. Dead Mario. As you can see, it's a Mario that is falling down. Oh, yeah, sorry. You're paying attention, actually. Very good. Yeah, so this is spoiler. It works. Anyway, so what you have here is a Dead Mario, which is a Mario that jumps up first and then falls down. And you can see it. You have seen it just now happen. We have the barrel here, which is this barrel here, this nasty little critter. And we have the asset, which is Mario. Again, this is, if you want to know what this Mario things look like, so how you actually create sprite sheets, that's quite simple, and it's actually being copied for doing sprite sheets for web pages. By a sprite sheet, oh wow. It's just, the series of animations. Yeah, it's the step, as I was saying. And as the frames go on, you just show the first, the second, the third, the first, second, the third. And lo and behold, it moves. And the barrel is also equally an impressive 4 frames. Okay, going back to something more sensible here. Okay, this time, don't save. Okay, so what do we have? We have the barrel, we have the asset going down, the barrel asset, And that's it. So the only change that we did, and again, this is the wrong window. I was like, okay, there is no change. What have I done? And instead, there is a change, which is going to be the collision. Yeah. So this, say, if there is a collision between hello, which is Mario, and the barrel, then die. Yeah. So I substitute Mario with the new dead Mario, and all this does is just makes it jump down. Collision is that code that I've shown you. Yeah, just see if basically this is saying is 0.1 of Mario inside the barrel rectangle, or 0.2, 0.3, 0.4, and if any of them is in, then he's dead. So just trying this, and I know there is a way here to refresh it. And this is starting to get annoying, so I will probably move to, yeah, it's time that I do this. I'm just going to move this to the actual browser, because it becomes a little bit awkward now. Okay, because here I can press refresh and start again. Yeah, and there you go. So you can jump it, yay, and if you're not very good like me, then yay. So, thank you. Okay, so, I mean, what is it, 150 lines of code, and this is, veritably speaking, a game, right? I mean, you have a challenge, you have enemies, you can succeed, you can fail. Of course,
you need a score.
Yeah, you need a score.
And then you have a Flappy Bird.
Yes, exactly. Well, it's easier than Flappy Bird. Yes, what you actually need is to package this, right? And this sounds like, okay, and then there's trivial stuff, right? In fact, you spend more time sort of polishing up the game by far, like 95% of the time is not the main game mechanics. 95% of the time is actually polishing the game. So adding the score, adding high scores, adding the music and the sound, and a bunch of other things. So these are important, though, because they make your game look really professional. And so F12, F11, here we go. Making code in front. Okay, so it's important to do things. Music and sound are important, right? They are trivial. The sound effects are super trivial. You can just load them and then go play. That's it. So when I press 3 here, it goes play. That's all this does. Yeah. Trivial. Thank you, JavaScript. Music is a little bit more complicated, simply because you need to repeat it. That's it. You have an event at the end. You can say play the next song. There's literally nothing else to do. So with this, we're done, but sound effects are important. And when I'm going to demo the game, you will see the sound and the music. They make it look like, wow, it's really cool, and whatever. Or maybe it sucks, but I think it looks really good, and that's because of the sound. Another trick is fades, that if you can put in fades. So what are fades? Fades are when you have like one screen, like game over, and then you want to go to the high score, and you can just either stop drawing the high score and stop drawing the game over screen, start drawing the high score, or you can fade one to black and then fade the other one back in. It's like a little trivial thing, but is usually very effective. So these kind of things you can do very easily if you think about it, if you are using this loop, right? So when you draw, you can just set the amount of color you want to put in and do these fade effects. And it's really easy because you're literally redrawing everything every time. So you're just changing one parameter and the fade is done. So what are scenes? Scenes are what I was saying. So you have an intro screen, you have a game level, and you have high scores, and you have other things. So you need to create some sort of tool, and here I'm going to be very, very, very generic. So for example, in Donkey Kong, right, so you have the starting screen, and then when you start the screen, you have a game intro, right? And then there is a level intro before every level, then there is the level, and the levels are different, and then there is an outro at the end, and so on. There is a name registration, and insert coin screen, and so on. So these are scenes, and you need to create a system by which you manage the screens, right? So this is how we built it. And there is a scene manager that organizes the movement between the scenes. So it tells it, okay, from the intro screen, you go to the level intro screen. And then from the level intro screen, you go to the level, and so on. And then a scene, which is basically a container that tells you what is going to be drawn, and is the game as I've shown so far. There is the main loop, which was still there, and the canvas, which is just abstracted away. So it's quite simple, and I'm not going to go into details because this is really starting to look like enterprise code, and I'm sure that this talk is the opposite of enterprise code, so that's all you get. No more boxes and arrows. And that's it. So let me, before I show a demo, let me just recap what I tried to show you today. So the main loop, clear everything, redraw everything, wait 30 milliseconds, do it all the time. Second, sprites and assets allow you to load everything at the beginning, and then you can create small, lightweight objects as you need to track stuff on the screen. Keyboard, not via event handling, but by using a set, so you can handle a bunch of things at the same time, a bunch of key presses at the same time. Hit detection, bad math, tedious geometry things and vectors. That is what it looks like. There's no easy way to do it, sorry. But yeah, I'm sure we can figure it out. Music and sound, easy stuff. Just remember to put them in because they're awesome. And find scenes. You need to think about expanding your game, putting more stuff in, because all this stuff makes it look really good. That's it, game over. So before we go to game over, let me show you the game. And this is the moment in which I either succeed or fail, because you never know. Here we go. So, and I should stop playing this. So if we go back to the beginning. Okay, so this is the game. Now we can actually show it. Hopefully the connection is good, because of course at the beginning you need to load a lot of assets. Yeah, there we go. Okay, so this is the game. There is an intro screen. Okay, this is one of the things which I didn't spend time on. As you can see, it's really bad. There's the high scores. So what you can do different things, instruction, credits, and so on. But mostly you want to see the game. So you go, you are your spaceship. You can move it around, and then you can shoot. And there's these baddies. Now you can see why I needed to create assets and sprites, because there are so many things on the screen at the same time. And this is just the first level, so it gets harder. But as you can see, putting music and sound actually make it look, oops, I got the bad, damn it. Okay. 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 I swear I did the high score. It's mine. I did not cheat. So there are many levels. There is also a, how do you call it? A bonus level in which, okay, enough, I just can't play this. It's just, people are looking at me, I suck. Okay, die, okay. Anyway, so, yeah, there is also a bonus screen in which it's very easy to kill your enemies, so you can kill all of them and so on. So there are 20 levels. You can write your high score. Of course, I didn't score anything, but it's there and so on. So this is the game, and it took me maybe 4 weekends to put it together. Mostly trying to find the right sounds and stuff. So it's not that hard. But then that's it. So game over now. Thank you very much. Thank you. By the way, before I forget, one last thing. Yeah, If you are interested in the code and want to see, there's a GitHub repo, of course. Just go in there. There's all the code that I showed today. And you get your Mario jumping game. OK, that's it. Thank you again. Any questions?
Right here on the left-hand side.
So yeah, this is exactly the level of game development I'm in, but just in different technologies. The one thing that surprised me, that you didn't separate your update and draw loop. Is there a reason for that, or you just didn't have like performance issues?
Didn't have any performance issues.
Okay.
Other questions?
As I said, I was expecting to do that. And then I said, OK, it's not trivial to do. If I have problems, I'll do it. And then JavaScript is fast. It's really fast.
Hello, nice talk. I have one quick question that is usually a problem with most of JavaScript games is how do you combat cheating because all the code is on client side? So, for example, in most of these games, you can render the character off canvas and the collision will never hit the meteorites will never hit and he'll have an infinite score. So
well, you can't really deal with cheating, right, with this kind of game because it's in JavaScript and it runs in the browser. So if someone wants to literally take all your code and create a slightly different version of the game in which they always win, they can do it. It's part of the technology.
That's part of the game, right?
As you can see, there was a guy before that was just like writing high scores. I mean, you can say it's part of the game, that too, right? So if someone finds that fun, let's let them do it.
Okay. Hi. You said that someone tried to cheat on the scores there.
Yeah.
How did you prevent that? So I cannot just do some request over the server and save my score.
Yeah, that's pretty much how it works.
So can you just explain how did you do it?
How did they fail?
Yeah.
Oh, because I saw it.
Yeah, he didn't block it. You can just do that.
I mean, it's very simple. It's not like I have it's not like World of Warcraft, right? There are 11 million players. This is like, okay, I have to beg people to play the game. So